living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Where we glide, from the peaks to the seas, exploring with ease. Mapping the future's bright, our bond ignites the night. Collaborate, innovate, together we elevate. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see an old technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Tech beehive. In the heart of the tech beehive. In the heart of the tech beehive. You can see through panoramic screens, living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. The freeways are wide, to the world where we glide. From the peaks to the seas, exploring with ease. Mapping the future's bright, our bond ignites the night. Collaborate, innovate, together we elevate. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see an old technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Tech beehive. In the heart of the tech beehive. In the heart of the tech beehive. heart of the galaxy where the stars align, we gather as a community with a vision so divine. Panoramic views, a world we can explore. With Liquid Galaxy, we open up the door. Echoes of the galaxy in every beat we play. Innovation shining bright, lighting up our way. Together we create, with passion and with pride. In the Liquid Galaxy, our dreams and worlds collide. Spatial wonders unfolding at our feet. A journey through the cosmos, a visual retreat. From mountains to the oceans, we see it all so clear. With every map and image, the universe draws near. Echoes of the galaxy in every beat we play. Innovation shining bright, lighting up our way. Together we create, with passion and with pride. In the Liquid Galaxy, our dreams and worlds collide.
Hello everyone, my name is Rohit and I am here to present my application for Build with AI contest. So this is a simple application where you can just enter your prompt and it will give you some results, and on the basis of results it will redirect you to different places onto the Google Earth, and also gives you a balloon on the rightmost screen. So let's see how this works and get the feel of this. So I will going to first go to the settings screen, and here you can see that I have already set up my Gemini API key. So you can also put your own API key in case to run the application. So now I'm going to change the, so since I've been previously I was working with the emulator, now I've changed. So if now I'm going to connect this. So let's connect to, yep, so you can see this is connected, and most probably it will redirect us to Lleida. So you can see that we have been redirected to Lleida. Now let's test the real functionalities. So first of all I'm going to send here hi. Okay, you can hear the voice that hi there, how I can help you today. So this is a simple text and it will be shown on the rightmost Liquid Galaxy screen. Now if I try cleaning this, so I can also clean it. So you can see that this has been removed from here. Now even we can do one more thing is we can let's say explore, and I want to explore Taj Mahal. So let's send this. Okay, so let's wait for a moment while it generates the required content for us. So you can see that the content has been generated and it will going to redirect us to Taj Mahal directly. Yeah, so you can see that we are now at Taj Mahal, and you can see this image, and also it is leading us to different places, and which is basically related to that only place. So if I say, let's say explore, and if I tell him to tell it to explore India, and then let's send it. So now it will generate some of the places along with some contents, and you can see that we have been redirecting to the different places in India. So you can see there's the first place is Delhi. You can also hear the voice that is coming from this audio section, so you can mute it. So you can click on to mute this. Now you can see that we have been redirecting to different places based on the content that has been generated. So how am I doing this? So basically the first content is being generated, that content is again used by the Gemini API to recognize if that content is a place or not. If that is a place, then it will again send to the our maps API key, where we are getting the coordinates of that place, particular places. So this is how everything is going into the backend. So this is pretty stuff, and since it is being given us in the markdown, so this is not being passed actually. But yeah, this does our work. So you can also clear this history, so you can continue, and everything will be cleared. And yep, so this was everything, that is say what is liquid galaxy, for instance, and if I send it there, let's see what happens. So hopefully we get an answer. So this is this is a pretty good, so uh, explain this liquid galaxy in one line. Okay, so you can see that Liquid Galaxy is a paranomic multi-display system that provides immersed Google Earth and geospatial data experience. So when the text is too long, this doesn't appear onto the rightmost Liquid Galaxy screen, because this is not this is not scrollable. So that's why the size doesn't fit, and hence the text is not being rendered in the rightmost screen. Yeah, so that's all for this application. Hope you liked it. Thank you. So hello mentors, I am Rohit, and today I am here to present the AI tools that I'm going to use in both of my projects. So the projects are CBT Visualizer and Time Space Explorer. So in both of them I am using the Gemini API to fetch or to generate the contents. For image generation I am using Gemma 3. For image generation we are using Imagine 3, and for text generation we are using models like Gemma 2. So let me show you how we are doing it. So for example, I go into the Postman API, and we will show you that this is my curl, and which I got from here. So this is a Google AI Studio where we are having a curl to get the to integrate this into our application. So you can see we are using the Gemini 2.0 flash model, and now we are here to generate the content. So once let's go back. So if I show you the prompt, so this is basically going to give a result in the JSON format. So I have already given the prompt to generate a JSON array. So once done, if I send it, so we will going to get the text like this. So now after passing this text, then we will be deserializing this JSON, and then finally we will be showing it into our application and sending it to the Liquid Galaxy screens. So you can see that this is a JSON formatted string. After deserializing and removing the extra words, we finally get into show a proper JSON structure, and then finally represents the data models, the Flutter, and then finally deserialize this into the data models, the Flutter data models, and finally it can be then used in later on the application. So this was the Gemini. This was for the text generation. Now I will show you how I am going to generate the image. So here I am going to use this API. So this is yeah, so generate images using Gemini. So you can see this is again our rest. We have a curl, and then we are going to see this whatever image that will be generated will be in base 64. So hi, okay, so let's send this prompt. Once the prompt will be sent, so we will going to get a base 64 image. So yeah, you can see that this is what we are going to see, a long image, base 64 uh, code. So now if I go into my browser and then go to here and paste it there, so I am going to see this image. So this was the base 64 that was generated, and then I have successfully converted this to image. So we'll be utilizing the function or writing a function in the Flutter to decode this base 64 to images. So that's how we will send this base 64 uh, data directly to the Liquid Galaxy screens, as it supports directly. And for the application, we will parsing this to an PNG image. So that are the two things that I will be using, and in this while set up this application. So that's all, and thank you so much.
Hi everyone, this is Tanya Singh from Bangalore, India, and I'm a first year student studying AI ML. And my project for the GSoC 2025 is catastrophe visualizer. um, the goal of the project is real-time disaster visualization and integrating the data, like connecting multiple disaster data sources, and then we are converting that into or representing in a visual interface. And then we are also enhancing the situational awareness, like understanding the scale, impact, and the data. How this data will be presented in the Liquid Galaxy is, first we create, you know we fetch the API data at regular intervals, and then we parse into JSON or XML response into Dart objects, and then we are transforming the geographic data into KML format, and then we are establishing SSH connections to Liquid Galaxy systems, maybe and then we are transferring those KML files and control commands to Liquid Galaxy masternode, and then we are building a responsive UI which help us filtering and exploring the data. um, the things that will be presented in the Liquid Galaxy setup, or what will be displayed, is the earthquake data, the paths, the cyclone paths, the wide spreads, all the things, and the emergency alerts, and those zones, like the emergency zones, flood zones, and stuffs. Why this project is necessary or special, I would say, is it connects. Okay, I personally love visualizing things to understand them better. So I think this project is a very good way. It makes the thing like visual, like data management, easier and simpler to understand for the public level, or anyone can just simply understand them because they are visualized, so it's more easier to understand. It also creates uh, you know educational value or emergency response coordination. There are many benefits of this project, and I personally think it is a very good project that needs to be considered. Thank you.
Okay, so hello everyone, this is my video for building AI for the organization Liquid Galaxy. Now, for my introduction, my name is Tadavat Kumar and I am currently a university student studying in KIT University in India. Now, currently I am enrolled in the course of Bachelor's for Computer Science Engineering with specialization in Computer Science core. Now, the name of the project that I've submitted for the GSoC is QuakeSafe. And as the name implies, the goal of my project is basically to make the Earth quake safe by predicting earthquakes. Now, how it would be doing that is by implementing AI models to predict earthquakes beforehand in real time. Now, how it would do that? Firstly, let us take a look at how it would get the data for it. And so it would take basically two datas, and that would be firstly the OLR data, which is present on the screen right now, and the ground deformation data, which we'll get from other API. The OLR data would be taken from the no API, which you can see right here on the screen. And as for the where is the data, you can publicly access it right here. This is basically all the data they have for the OLR for many multiple years. And if you choose to select and download it, you will just get an inventory in .nc format. Now, even though it's in .nc format, which can be converted into CSV, we will directly using the .nc format to save us some space. Now, other than that, let us have a look on the dataset that I have beforehand with me. You can see right here the dataset that we got has time, latitude, longitude, and OLR. So the time basically tells that it is for one specific day, and it basically summarizes for one day in a nutshell. And as you can see, with the dates increasing, it changes. Now, other than that, it covers for all the longitudes and latitudes for each day. As you can see right here, from -90, it goes till 90, and all the 360 degrees for the longitude, and all our data which is unique for each and every one of them. So that is basically what data we will get from our OLR API. Now, secondly, from where we will getting our ground information data would be the IQ's API, which would be taken from this website initially, but since they are migrating their website, so we will be going to the new website, and from there we will take the data from the data tool, which is right here, GNSS data. Now, as you can see right here, it looks pretty similar to what they had it right here, so we'll be using that. Now let us take a look for the yesterday's data. As you can see right here, it is properly showing all the ground information data that we need. For example, GPS, GLONASS, and even the earthquake data if we miss any beforehand. So let's take a look for one of the earthquakes around Japan right here. As you can see, it has highlighted the earthquake, and if you try to click it, it shows you all the information and the time as well as the data that has been recorded by the stations nearby. Now that concludes both our OLR and the ground deformation data. Now how we will be using this data to take the earthquake, and that is quite simple. So basically, if there is anomaly in the OLR value beforehand, and an anomaly in the ground deformation data, which can be seen quite days or even months before an earthquake occurs, then we can be ascertain that an earthquake might take place. And that is how simply we will make our earthquake prediction model. Now, as for the AI architecture that we'll be using, so we'll be employing a Gemma API straight from Grok. Initially we were to use Hugging Face, but since it has updated its free tier scheme, I think Grok is more feasible. Now, other than that, the AI techniques that we'll be using on it would be the time series forecasting model, because as it is quite implied that we will be dealing with real-time data, so we would need a model that can predict with real-time results. Other than that, we would be fine-tuning the model so that it can give us quite accurate results, as we would be training the model on the historic earthquake models and then testing it out on real-time earthquakes such as the one on your screen right there. Now, that basically sums up all the AI techniques and the overlay structure of my proposal. Now, why am I proposal is special? I think it is pretty self explanatory if you look at the topic, which is earthquake prediction. Earthquake prediction, in my opinion, is very overlooked, and I think it is something that has a high potential with social benefit. Now, if we can predict earthquakes even a second before, then that would help nations as well as people to be equipped beforehand and save a lot of lives as well as the damage that is caused, such as property damage, etc., etc., and save them the time that is costed during the recovery from the earthquake. And if we are able to do that, I think that would be a worldwide impact that can be created from just one project. That is why I think my project is special and should be chosen for GSoC. With that, I would like to conclude my video for building AI, saying that thank you.